I'm not going to require you to do any proofs using identity elimination, um, at least not any that count for credit on the final exam, but there may be some bonus proofs that use it. And I wanted to give you a brief introduction to it in case you're interested in it. So identity elimination is a rule that allows us to replace some constant with another constant when we know that those two constants name an identical object. Okay, so according to our system, sometimes a single object can get two names. And so our identity relationship is the relation that obtains when two names name the same object, when A is identical to B, okay? Sometimes this may not be known to us, so you may not know, for example, that the morning star is the evening star. That could be a discovery that you made after doing some astronomy. But in some cases, then we will know what the names refer to. But in any case, if an object A is identical to an object B, then what that means is that every property that A has, B also has. So if we have some sentence that attributes a property to A, then we can substitute the name B in for that name A wherever it appears and get a true sentence. This rule and identity in general is particularly useful when used with our quantifiers. And some proofs make use of this rule. Okay, so here we see the details of this rule. So according to identity elimination, if we're given a sentence, here given at step M, that A is identical to B, and then we have some other sentence N at step N, sentence phi, in which either the name A or the name B appears, then we can either assert that if it is B if it is A that appears in phi, we can substitute in B for any instance of A using identity elimination and citing these two rules, the identity statement and also the sentence containing the letter A. Additionally, if B had have appeared in phi, then we can substitute in A using the same rule, identity elimination, and citing again M and N. So let's see this rule at work. Here we are given the following. We are given the statement C is H. We are given the statement that A is identical to B, and the statement that B is identical to C. And now we want to conclude that A is H and also that B is H. So how do we do this? Well, it's very simple. At step 4, what we're going to do is we have H is C. So we can assert here using this sentence, H is C, and this sentence, B is identical to C, we can assert that, I said H is C earlier, I meant C is H. We can assert that B is H using identity elimination, okay? So the rule there again is going to be identity elim from 1 and 3. Additionally, at step 5, we can assert that A is H. And that again will be universal, I'm saying universal there, I meant identity, using identity elimination in both of these instances. So we're going to cite identity elimination here from 2 and 4. And now it's a simple use of conjunction introduction to get our desired goal. And that's it. Bye-bye.